Hey everyone. Let's see. Welcome to the online learning of college algebra. This is exciting. This is really cool. We're using a lot of really cool techie things to get things done. Yes, now, let me start off with this. I haven't heard a lot from you all yet, and that's fine. So I assume it's going well. So congratulations. Good job on all the work you're doing. And by the way, great work on the work yesterday. Overall, you all seem to really be getting the material and getting it down, and that's really encouraging. If you are having any trouble getting to the assignment or accessing Khan Academy, just let me know. I can help you point you in the right direction. But if you are having trouble with these problems specifically, please let me know about that too. I'd really be happy to work with you. In fact, you're welcome to do these next few weeks on your own. But you really are paying me as a resource to help teach these concepts to you, to help you every step of the way. And really, that's what I intend to do. I intend to help you every step of the way here. So really, please utilize me. Let me know how I can help you because I am here to teach you these resources, not just to be an aid. Um, I, please do email me with questions and what you'd like me to cover. I hope to do more videos to really introduce concepts before you tackle them, and we'll see how well I can do that, especially with the fact that I'm trying to make sure that all the teachers are ready to do things and they have everything up and running. But yeah, I hope to give more videos than just this. What I hope to do in videos like these, though, is show problems that are really giving us the most trouble in the work that we're doing, or really just gave us the most trouble, and then walk you through the process of how to do those problems. So right now I'm using OneNote, and the link to access this whiteboard for yourself is actually in RunWeb. So feel free to reference this notebook at any time. I'll try to continually update it with tools and strategies and solutions with the most difficult problems that we have. But without further ado, this is the most difficult problem that we run into as a class. And I like to just tackle through it and walk through it and see what the steps are to really solve something of this nature. The question says solve for y and reduce any fractions to the lowest terms. Don't round your answer and don't use mixed fractions. Okay, so the most, what it gives us here is 5y plus 3 is less than, or sorry, is greater than negative 7y plus 13. Now you notice this is an inequality, and that's really important here. Well, I hope that doesn't, something just happened to my screen. Okay. You notice that this is an inequality here. And the most important thing to realize about inequalities, that just means there's one extra rule we got to worry about. It's exactly the same as equations, but there's one extra most important rule. And here's the rule. If you divide or multiply by a negative when using an inequality, that means you have to flip the direction of the sign. So for example, if I was to take both sides of the equation and divide it by 2, divided by 2, I would have to flip this sign to become a greater than, And so if it was, for example, if it was greater than or equal to, did I say greater than? I mean less than. For another example, this was if that sign was a greater than or equal to, we shift it to a less than or equal to. So the point is, we just take whatever sign is there and reverse its direction if we divide. But apart from that, it's really just the process of solving an equation. And here's the process of solving an equation. The first step is to get all letters or variables, that's what a variable is, it's just a letter, to one side of the equation. The second step is to combine all like terms, which is all of that variable, so there's only one letter, or in our case, what we see here is just only one y. Then after that, we get the variable by itself. So we get rid of the numbers around it by doing the opposite of what they're doing. And we'll get into a little more of that in a second. But let's start with the first step. The first step is to get all of the letters, all of the variables to one side of the equation. So you notice there's a 5y on the left and a negative 7y on the right. So that means you have to get both of those on one side of the equation. So you have to do something to get rid of one of them. What we can do is we can take this negative 5, we can take this 5y and get rid of the 5y. So to do that, we can subtract 5y and subtract 5y. And what this does is it gets rid of the 5y on the left side and leaves us with just y's on the right side. So now we have 3 is greater than negative 7y minus 5y plus 13. Excellent. So now we have one finished. All of our y's on the one side of the equation. So again, yeah, usually using additions or subtraction, in this case we subtracting 5y, is all you need to do to get all the variables to one side. Okay, once you've done that, we combine like terms. So there's only one letter. So you see there's a minus 7y and a minus 5y. We'll combine those into one. We'll make that a minus 7 and a minus 5, or negative 7 and negative 5. Those together become a negative 12y. So these become a negative 12y. And the rest stays the same. So you got 3 is greater than negative 12y plus 13. So that's step 2. Great. And step 3 is get the variable by itself. Okay, now here's the process for getting a variable by itself. The first thing you want to do is get the variables, the numbers that are furthest away from the variable, and deal with those. So here's what we need to do. We've got all of these numbers on this side of the equation. If we could get it down to just being y, we'd be done. We'd have this thing solved. So that means we need to get rid of 2 things. We need to get rid of this negative 12 that's being multiplied by y, and we need to get rid of this 13 that's right next to, but that's not even close to y. It's kind of far away from y. If we can get rid of those 2 things, we'll have something is greater than or less than or something. We'll have something is greater than y, and we'll be done. Okay, so we got to choose one of these 2 things to get rid of first, either the negative 12 or the 13. Well, 3a says it's best to start with the numbers that are furthest from the variable. That is just, there's ways you can go about it otherwise, but that really is the easiest way. So the number that's furthest away from the y is this 13. And you can tell why, because the y is being multiplied by the 12. And so they're stuck together. They're almost like one thing. So we will need to just get rid of that. We need to get rid of the 13 because it's a bit further away. It's got a plus sign in the middle of it, but away from it. But that 12 and y are right next to each other. So we want to start with the 13 is what we want to do. To get rid of the 13, we can say, to get rid of a number, all we have to do is the opposite of what it's doing. So right now, a 13 there's negative 12y, and we're adding 13 to that negative 12y. So to get rid of the 13, we want to subtract 13. So if right now we're adding, we want to subtract 13 and subtract 13. So because remember, whatever we do to one side of the equation, we have to do the other side of the equation. So we're going to subtract 13 from both sides. Now, if we subtract 13 from this right side, these cancel out. Great. And we're left with 3 minus 13 on the left side. Well, 3 minus 13, that would be negative 10. So, right, negative 10 is greater than negative 12y. Great. Okay, so you've got rid of the 13. Now we need to finish with the number that's right next to the variable. There's this negative 12 times y. We want to get rid of that negative 12 times y. So what we'll do is we will, let's see, if there's 2 numbers together, there's a 12 and a y. That means it's 12 times y. There's an imaginary multiplication here. So what we need to do to get rid of the multiplication is divide. Okay, so you got negative 12 times y. We'll need to divide by negative 12. But remember, what we do to one side, we have to do the other side. So we'll do negative 10 divided by negative 12 as well. Okay, so we're multiplying by 12 on the right side, and we're dividing by 12 on the right side, which means we can cancel them out. That becomes just y. But here's an important rule. I hope you haven't forgotten it. It's easy to miss this. It's the most important rule for inequalities. Again, if you divide or multiply by negative, we have to flip the direction of the sign. And what we've just done is we've divided by negative. So we're going to flip this sign. We're going to flip that sign to be a less than. Okay. So that leaves us with negative 10 over negative 12 is less than y. Okay, the last thing we need to do, simplify our answer. And here's how we can accomplish that. Well, simplify, what the word simplify just means, it means just to reduce it down, reduce the fractions, bring together any addition or subtraction or multiplication or division, do any parentheses you can do any exponents you can do, just do everything to make it as a small and concise and neat problem as possible. So see if there's any way to make it use smaller numbers, or use fewer terms, just something to make it easier to work with. Okay, so we've got a negative 10 divided by negative 12. Hey, that's a negative divided by a negative. A negative divided by a negative is just a positive. So we can rewrite this as 10 divided by 12 is less than y. Okay, so 10 divided by 12 is less than y. Maybe we can reduce the fraction a little bit. We know that with fractions, one of the things we can do to reduce them is we can divide the top and the bottom by a number. And if we can divide the top and the bottom by a number, then we can reduce it down a bit. So is there any number we can divide a 10 and 12 by? Well, we can try 2. They're both even numbers, so we can try dividing by 2. Divide by 2, divide by 2. That gives us, let's see, 10 divided by 2 is 5, and 12 divided by 2 is 6. So you get 5/6 is less than y. Is there anything else we can do? No, it looks like that's a 5 and a 6. There's no way we can reduce that fraction down. It's a positive number. That's a positive fraction. So for all intents and purposes, I guess we're done here. That would be done. We can call it done. So 5/6 is less than y would be our answer. If you wanted to go very technical and get a number, a physical number, you could take 5 divided by 6, and we could say, well, that's 0.83. So if you want to be really fancy, you could say it's, we could say it's 0.83 repeating is less than y. But you probably don't want to even do that. That's not worth doing. So that's how we do the problem like that. Let's move on to the next most difficult problem. The next most difficult problem was this one right here. It asks the question, which of the following equations has exactly one solution, or have exactly one solution? And says check all the answers that apply. Now, let's first refresh your memory on what solution means. A solution is just a value you can use for x that will make both sides of the equation equal each other. So if you get like 3 equals 3 or 4 equals 4, or something, if you find some number to make some number you put in for x that makes both sides equal each other, well then that's a solution. You've solved it. So there's sometimes problems have 0 solutions, sometimes problems have 1 solution, sometimes problems have infinite solutions. If it has 0 solutions, that means it doesn't matter what number you put in for x. It won't work. Like there's no number you can put in for x and make both sides of the equation equal each other. Sometimes if you get like a 1, if there's like 1 solution, that means there's one number. You get x equals 3 or something, which means if you plugged in 3 for x, you get both sides of the equation to equal each other. Now, if it was like if it was infinitely many solutions, that means it doesn't matter what number you put in for x. It will always, both sides of the equations will always equal each other. So it really just boils down to the steps of the problem. So when you try to solve the equation, you can see the steps on the right side. When you try to solve this equation, if you get something like 7 equals 7, then it doesn't matter what number you choose. I could choose any number for x. So this reduces down to something like 7 equals 7. I could say like x equals 3 or x equals 4, x equals 20. It doesn't matter what x is because 7 will always equal 7. So if we reduce down this equation, if you try to solve the equation, you end up with something like 7 equals 7, or 12 equals 12, or 15 equals 15, then it doesn't matter what value for x you choose, it will always work. So that means that 2 is a solution, or 5 is a solution. We've got infinitely many solutions. Let's say we had a problem like 3, let's say we came down to like 3 equals 4. If it became like 3 equals 4, then that would mean it really doesn't matter what number we choose. Again, so if I chose like x equals 2, well 3, it still gives us 3 equals 4, and both sides of the 3 does not equal 4. Both sides of the equation don't equal each other. If I chose x equals 7, we'd still get 3 equals 4, and so it really doesn't matter what number I choose for x. The answer is always going to be 3 equals 4, and that won't work for us. But if you get something, so what that means is that there's no solution. Sorry. And then for the last one, if you get something like 3 equals x, well then that means that there is one solution. It's 3. If you plug in 3, you'll have the answer. Okay, I'm very long-winded. Let's just get through the problem. Let's get through these and see what we find. So the first one is negative 6x minus 6 equals 103x minus 103. Let's work out what that means. So negative 6x minus 6, let's just say, equals 103x minus 103. Okay, let's do our processes again. These are the steps to solve the equation. We're going to get all the letters to one side of the equation. We're going to combine like terms, and we're going to try to get the variable by itself. So let's see. We can add 6x to both. There's 2 x's on both sides, so we're going to add 6x plus 6x. And again, what I'm doing is a negative 6x, and I'm going to do the opposite of negative 6x to get rid of negative 6x. I'm going to add 6x, and I'll to both sides. And I could have subtracted 103x, but I don't need to do that. I mean, I would get to the same answer. That would also work. It'd be fine. But just for the sake of simplicity, I'm just adding 6x. Both work just as well. Okay, so minus 6x plus 6x, those cancel out. We're left with negative 6 equals 100. Let's see, 103x plus 6x, that's 109x minus 103. Okay, let's see. All the letters are by them, all the variables together. We've combined like terms. It's all just one. There's only one x on the table, so we're good there. Now we just need to get the variable by itself. So let's see. We'll get rid of the thing that's furthest away from x, which is 103. So we'll add 103 on both sides. Okay, and that gives us. Let's see. These cancel out. So that gives us. We get negative 6 plus 103. Well, that's kind of hard to do in your head. An easier way to think about it, when I see a problem like this, what I can think of is 103 minus 6. Those mean the same thing. If you have a negative plus a really big positive, you can kind of switch them around and have it like a positive 103 minus that number, minus the negative. So we have 100. It's kind of the same thing as saying 103 minus 6, which would be, let's see, 103 minus 6 would be 97. So this would be 97 equals 109x. And so let's see, we'll divide both sides by x. Sorry, divide both. The last thing to get rid of in order to get x all by itself is 109. It's 109 times x, that imaginary times. So we'll divide both sides. We'll do the opposite of times. We'll divide 109. Divide by 109. These 109s cancel out. So we get 97 over 109 equals x. Well, hey, look at that. That works out. So x equals 197 over 109. So if I plugged in 97 over 109 in for x, that would be an answer. Like that would be a correct answer. So A is good. A is good. We're going to fill that in. Okay, let's try B. B says 103x minus 6 equals 103x minus 103. So B, 103x minus 6 equals, is that 103x minus 103? Yeah. If you're very clever, you might already see what the answer might be. But it takes a few steps to figure this one out. So let's start it. So if we have, even if you're not, even if you're very clever, you might not see it. It just, sometimes if you've done a ton of these problems, you might, and you've got this lesson down. If you can see it from here, then you probably don't need to listen to the rest of this video. Let's work this out. 103x minus 6 equals 103x minus 103. So we need to get all the variables together. Let's see, there's 103. Let's get the 103x's. Let's get that x to the right side. So we'll subtract 103x. I can get rid of the 103x above it. But what I do to one side, I have to do the other. So we do minus 103x. Let's see, that cancels out. But 103x minus 103x. Well, that's just 0. Those cancel out too. So that gives us negative 6 equals negative 103. Well, that's a problem. That's not true. So negative 6 doesn't equal 103, which means that is case number 2, or case number B, when you get two numbers that don't equal each other on the equal sign, which means there is no solution for B. Okay, let's try C. C is negative 6x minus 6 equals negative 6x minus 103. So we get C, negative 6x minus 106 equals negative 6x what is that, minus 103? Yeah, minus 103. Okay, we're gonna do the same thing, get all the variables out of the way. So let's see, there's a minus 6x. I'll get rid of that minus 6x by adding 6x. That way, I'll get all the x's on one side of the equation. What to do on one side, I have to do the other. So plus 6x. So we get, these cancel out. Oh, and again, minus 6x plus 6x. They cancel out. So what we're left with is negative 106 equals negative 103. Well, that's wrong too. That's definitely not, those definitely don't equal each other. So that means that creates a problem, just like B created a problem. That means C is no solution. And finally, we're left with D. Negative 103x minus 6 equals negative 6x minus 103. So D. Negative 103x minus 6 equals, is it 6x? Negative 6x minus 103. Okay, let's see. Let's get them both on, let's get rid of the x's, so it's on both one side of the equation. I could add 6x both sides to get rid of the 6x on the right, but I think I'll just do what we've always been doing so far and just add 103x to both sides. I'll get rid of the 103x on the left side because that cancels out. And so we're left with, what is that? That's 6x. That's 6x plus 103x. Okay. So that, let's see, negative 6x plus 103x. Oh, we did that before. That is 97x. Because negative 6 plus 103 would be 97, which is 103 minus 6. Cool. So we get negative 6 equals 97x minus 103. All right. Let's see, we need to get x all by itself. So we'll start with the thing furthest. We'll start with 103 plus 103. And that gives us, let's see, these cancel out. So that gives us negative 6 plus 103. Again, that's 97. 97 equals 97x. And finally, we will get rid of that 97 that's being multiplied by x. We need to do the opposite of multiplication. We're going to divide. So we'll divide by 97. Divide by 97. Let's see. This cancels out. These cancel out. And let's see. 97 divided by 97. That's like, what is that? That's like 2 divided by 2, or 3 divided by 3, or 4 divided by 4. Anything divided by itself. Well, anything divided by itself is always going to be 1. So we'll say that is 1 equals x. And it's interesting. Be careful. This is not 0. We're not getting rid of it entirely. It's just the same number divided by itself. If it were 0, the only way to get a 0 in a fraction, remember, you might remember what this is. That's 0 divided by 97. That's what would result in 0. But a number divided by itself, that's just 1. Because you're saying I've got 97 pieces of pie, and I'm going to share that with 97 people. Well, so each person gets 1 piece of pie. So 97 pieces, 97 people, and so each person gets 1 piece of pie. So that's the way that helps remember how to use fractions. If I had 0 pieces of pie and I shared it among 97 people, 0 pieces and I shared it among 97, that means that each person would get, well, 0 pieces of pie because there's no pie. So anyway, I hope this is helpful. If you do have any more questions, please shoot me an email. I'd be happy to work with you personally and just help you in any way I can to help you master this material. If you want more videos like this, let me know. If you have any topics you want me to cover, I'd be happy to do so to help you as best I can. Cool. Good luck.